In this problem, we will conduct a test of significance for the population proportion P. Here's our problem. The community college in your town is having a difficult time accommodating parking for all of its 3,000 students. The college believes that a smaller percentage of students carpool to school as compared to the national average. According to the 2000 U.S. Census Bureau estimates, it is believed that 12.2% of all Americans carpool to work. The college takes a random sample of 130 students and finds that 12 of those students carpool to school. Is the school's belief supported by this sample? We can answer that question by doing a test of significance. We want to test a claim about a population proportion. So let's first define what our population proportion is. The population proportion P is the proportion of college students who carpool to school. We're now ready to write our null and alternative hypotheses. Our null hypothesis is that the proportion of college students who carpool to school, P, is the same as the national average of 12.2%. Our alternative is going to be one-sided because the college administrators believe that the proportion of students carpooling to school is less than the national average. Not only should we write our null and alternative in symbols, we should also write it in English. The null says the proportion of students carpooling is 12.2%. The alternative is that the proportion of students carpooling is less than 12.2%. What conditions must be necessary in order for us to do this test of significance? We must have a simple random sample. N times P naught has to be greater than or equal to 10, and N times 1 minus P naught has to be greater than or equal to 10. And we must have a large population. The size of our population must be at least 10 times greater than the sample size. Do we have a simple random sample? Well, it says the college takes a random sample. We will assume that that random sample is a simple random sample. What is N times P naught? That's 15.86, which is greater than 10. N times 1 minus P naught is 130 times 1 minus 0.122, which equals 114.14, which again is greater than 10. So our second condition is met. Do we have a large population? 10 times our sample size of 130 is 1,300. The size of our population is 3,000. That is greater than 1,300. So our third condition is met. So we can conduct the test of significance in this problem. We are now ready for our z-test statistic. What is the formula for our z-test statistic? It's p hat minus p naught divided by the square root of p naught times 1 minus p naught over n. P hat is 12 over 130 minus p naught is 0.122. We have the square root of 0.122 times 1 minus 0.122 over 130. This quantity equals negative 1.03. Our test statistic for this test is negative 1.03. We now need to calculate our p-value. So our z-test statistic is negative 1.03, which means our p-value will equal the probability that a standard normal random variable is less than our test statistic. The probability that a standard normal is less than negative 1.03. Sketching our p-value, we have our standard normal distribution, normal 0, 1, with center of 0, standard deviation of 1. The blue shaded region indicates our p-value. Here is our test statistic of negative 0.103. The p-value is the area under the curve below that test statistic. we need to either go to a standard normal table to find that probability or use our calculator. Let's first do it looking at our standard normal table. When we go to our standard normal table, we see that we only have positive values for our z-scores, but we can use the symmetry of the normal distribution to help us answer our question. We wanted the area below 1.03, negative 1.03 to get our p-value. Because of the symmetry of the normal distribution, the area to the left of negative 0.103 is the same as the area to the right of positive 1.03. So if we can find this area, that equals our p-value. When we look up 1.03 in the standard normal table, we get 0.8485. That 0.8485 is the area to the left of 1.03. So to get the area to the right of 0.103, we have to take 1 minus 0.8485, and we get 0.1515. So the area to the right of 1.03 equals 0.1515. That also equals the area to the left of negative 1.03, which is what we were looking for. And we have that our p-value is the probability that a standard normal is less than negative 1.03. We just found that to be 15.15%. Let's calculate this probability on the calculator. Remember, we said we could calculate this probability either using the standard normal table or the calculator. Let's use the calculator and verify the 0.1515. On the calculator, if we go to second vars down to NormalCDF, NormalCDF allows you to calculate areas under normal curves. If we hit enter, we need to put lower bound, upper bound, mean, and standard deviation. Our lower bound is negative 10. We want to go all the way up to negative 1.03, so we want the area under a normal curve from negative 10 to negative 1.03. The mean of our normal random variable is 0. The standard deviation is 1. We hit enter, and we find that that area equals 0.1515, just like we have here. Now we're ready to complete our test of significance. To finish the problem, we need to write our English conclusion in context of the problem. Because our p-value of 0.1515 is rather large, what does a p-value of 0.1515 mean? It means that 15% of the time we would see our sample proportion of 9% or something more extreme if in fact the null hypothesis is true, or that the national average is 12.2%. Because we have our rather large p-value, we fail to reject the null hypothesis that the proportion of students carpooling equals 12.2%. Our test of significance is now complete.